This is a standard 20 by 4 characters LCD. It's based on an HD 44780 controller. I'm sure many of you know this and use this in your projects. What I don't see very often, and I guess not many people know, is that you can use these displays not only for normal characters, but also almost as a graphical display. I'm going to show you how to do this, and let's jump in. If you watch closely, you'll see that this display is made out of small areas. Each of these areas can be used to display a single character. So we have 20 of these areas on each line, and we have 4 lines. And if you look even closer, you'll notice that each of these areas is made out of dots or pixels. There are 40 pixels in here, and they are placed in a matrix of 5 by 8, 5 columns with 8 lines. So the whole character set, which means the way we describe which pixel should be on and off when forming a character, is stored in a non-volatile memory on this LCD. And you should probably do a search for the datasheet of this controller, HD44780. You'll see what I'm talking about. The nice thing about this controller is that there is an area called CG RAM where we can store our own custom characters. The only downside is that this memory is pretty limited. We can only define up to 8 custom characters. So let's start an example here. Let's say I want to display a symbol like, let's say a battery. I can draw this myself, and then I convert it to a numerical code and save it at one of those reserved addresses in CG RAM, and then I can use it in my software. So this symbol here is made out of 3 different characters, and you can see it spreads on 3 of this one single character surfaces. So in order to display something like that, all I have to do is to define these custom characters and then display one near the other to form the whole symbol. So starting from the left, our first character will be this. The second one will look like this. And then the third one like this. Then the next step will be to convert each of these graphics into a numerical code. And I'm going to show you the tool I wrote for this. So on the left side here, I can draw the character I want to define. And then if I press create, it's going to give me this array here. If you look close, we have 8 values, 1 for each line. Each of these values is the decimal representation of this binary sequence. And for each custom character, we want to define this array. That's all we need. It doesn't matter what language you're writing your software in. The algorithm is always the same. Draw your character, convert it to this array. It can be decimal or hexadecimal. And then instruct your LCD that you want to use the reserved addresses from its CG RAM, which is a volatile memory, to save a new custom character. And you're going to give this character a name, and whenever you want to use this character, we just have to instruct our LCD controller to display it. And that's it. It's pretty straightforward. If you go back to our little example here, I can do animations too, or I can create other similar characters. Let's say I want to display various symbols for different battery levels. This is my 100% battery level. I can draw another one to look like this. Let's say that will be like 65%. We'll use this when the battery goes, let's say 20%. And I have a last one for low battery, 5% and below. So I have 4 different symbols, and we can build all of them from 6 different characters. This first one using these 3 characters. The next one is built out of this. This one is built out of this, this, and this. And for the last one, we're going to use these 3 characters here. And by using the exact same technique, I drew the 7 segments, which I then used to create all the digits 0 to 9 to display the time on my radio clock. 7-segment display uses, like its name says, 7 areas which are illuminated or not to display a single digit. I'm going to draw one single digit here. And we're going to name these segments A, B, C, D, E, F, and G. So for instance, if I want to show the digit 2, we're going to have A, B, G, E, and D switched on. F and C will remain off. For a 9, I will illuminate the segments A, B, G, F, C, and D, and this segment will stay off. And so on. You can form all of these digits like this. And what I'm going to do is, I'm going to create these characters here, and I'm going to use them to create the digits resembling the 7-segment display. And this is like reconstructing bigger pictures out of smaller parts, just like solving a puzzle. I just have to arrange the custom characters to form a 7-segment digit. So for a 7, let's say I want to display the digit 7 right in the middle. We're going to have 3 characters on the first line. This one, and this one. And then we're going to move on the second line, and we're going to display this character here. And then we go on the third line, and we're going to display this one. And on the last line, we're going to have this character. So if you want to display a whole number, you just have to follow the same principle. You can write procedures or subroutines to do this automatically, and you'll only have to select the position on the display. And you can also do simple animations by overriding the same positions with new characters, or you can change the position on the display. And I hope you'll find this useful no matter what language you're using for the software. And no matter what hardware is going to control this display, this algorithm is always the same. And I think it's a great way to extend the capabilities of these displays. Instead of just using normal characters, you can now create simple graphics. The only disadvantage to all this is that the memory space where you can define the custom characters is very limited. Just like I told you, you can only create 8 of these 5 by 8 pixels custom characters. There is a small trick you can use. You can reset and then reinitialize your display with a new set of characters each time you need it. So anyway, thanks for watching. Please take a moment and subscribe to my channel if you haven't already. And if you enjoyed this video, make sure to smash that like button. That will help this channel a lot. Until next time, this is Core Weaver signing off.